Here's a blast from the past. This is a GRC 14 receiver. It goes back quite a few years. It's a military radio, and it covers 2 to 32 megahertz in 4 bands. And the modes it covers is CW phone and FSK, or frequency shift keying, basically teletype. A lot of limited information on the internet on this unit that I've been able to find. There's a few articles. I got one from 1960 that describes this. It's part of a unit that included 2 receivers and a transmitter that were mounted in a Jeep. So I imagine these were used back in the Vietnam era. It has 2 stages of RF amplification. Local oscillators, tunable in 2 ranges. It tunes 2.18 to 4.5 and 8.65 to 17.75 megahertz. It's single conversion below 8 megahertz and double conversion above 8 megahertz. Here's the band switch. You can see when I change the band switch, it rotates the different bands up in the top here, and then as you tune it, the scale moves to show the frequency. It's got a tuning indicator here for teletype, operation switch here, calibration, CW sharp, CW FSK, modulated CW, and phone. Now someone has modified this. It's got a different power connector here, and it looks like it's got an output for audio here. I'm not sure how this was done. This was picked up at a ham fest, so I don't know exactly what's been done inside. I'll have to open the unit up. It's pretty heavy. It's about 67 pounds. Welded steel or aluminum. I'm not sure what this is. I'll have to hook a magnet on it. But anyway, it's built like a tank, but for a Jeep. So I'll take the back off. It looks like it's got some screws here that come out. Okay, it's got some hex connector screws on here, cap head or whatever you call them. They use okay, say this thing's built like a tank. Weighs like a tank. Let's see, to get the back off, I think I will put the unit on its face. Boy, before the days of solid state. Okay, here's a view inside the unit here. I think it's well built, I'll tell you. Nice thing about this one is it'll operate off of 120 volts AC. It looks pretty intact. Here's a choke, 290 millihenry choke, and a power transformer, 115 volt primary, 81 volt secondary, looks like. Lots of adjustments. I'll have to try to find a schematic for this. Anyway, the fella I picked it up from said he could not get it to work. He doesn't know what's wrong with it. So, like I say, there's been a modification to the front panel to input 115 volts, and then there's an audio jack on it, it appears to be. I'll have to trace that out. Anyway, I'm going to hook it up to the dim bulb tester and see if we have any shorts in it. It's got gaskets to seal the thing here. Looks like this thing was made to go through some pretty rough terrain. Get a cord and plug it in the dim bulb tester and see what we get. I have the unit connected to the line through a dim bulb tester here, and I will turn on the power, and well, let's see what we got for current. $650 milliamps, which might be alright. Should we should we bypass the dim bulb and see what happens? I think I'll take a chance. $850 milliamps. I hear some humming. Pilot lamp's on, that's a good sign. And let's see. 92 watts. Is that normal? I have no idea. But at least we don't have any blown fuses. And I see some tubes are starting to light up. So the next step will be try to trace out the audio here, how they modified the connector here for audio out. Anyway, that'll be the next step. See if we get any output here through this audio connector. Not sure where this goes. I'll have to trace that out. Here's an article I found on the internet regarding this system. It's part of an AN/MRC-55 General Purpose Mobile High Frequency Communication Equipment. Now this was in Electrical Communication Volume 36 number 4, 1960. So if you want to look this up, you can on the internet. And this describes the system here. Here it shows the receiver. Boy, this thing is really well built. Modular construction. You can see here the IF amplifier with a plug-in. It's got a Amphenol type connector on it. Some more pictures, the tuning unit, receiver module, power supply. And here's the transmitter that went along with this system. It was made to hook up to a teletype or use a CW, Morse code, or AM phone. I won't spend a lot of time on this. You can look it up if you're interested. It's just 9 pages. Well, it's not completely dead. CHU Canada time signals. Gotta calibrate it. I'll hook an RF generator up. Can just barely hear WWV at 10 megahertz. All I have right now is a wire connected to the low Z antenna input here. Squelch is working. Gain's working. Maximum RF gain. The antenna trim doesn't seem to do much with this little wire I got. Well, I'm picking up some 40 meter CW. CW broad, CW sharp. Yeah, this unit needs a lot of work. Well, it's early morning. It's about, I think about 8:30 on Saturday. Well, this is interesting. I turned the gain down, and you can hear what sounds like a relay clicking in the unit. An FSK phone. FSK broad and FSK phone. I'm hearing a relay clicking inside, so it's kind of interesting. Not sure where that's coming from. But you can hear it. I'm inputting a 7 megahertz signal, 50% modulation, AM modulation, 5.5 microvolts, and I am receiving signal here. You can hear it. I'm going to drop the amplitude here. There's one microvolt. Nothing but noise. You can just barely hear the signal. There's two microvolts. There's 3 microvolts. The noise level's dropping a little bit. There's 4. 5. There's 6 microvolts. There's 7. Seems like I'm overloading the front end when I turn the RF gain up all the way. Let me back that down a little bit. Let's try 5 microvolts. Okay, there's 4 microvolts. And adjusting the RF gain. So it's not dead. Let's try 14 megahertz. A lot more noise. I'll run up the amplitude here. Let's go up to 8 microvolts. Let's go up to 10 microvolts. Well, BFO seems to be working a little bit. Okay, it's on CWFSK broad. There's 0 beat. Let's raise the modulation up to about 70%. Amplitude 15 microvolts. Don't have an S meter on this radio, unfortunately, but I could go in. I should go in and measure the AGC voltage. Maybe I'll do that. So let's try go up in frequency and see what we get. Now this is 14 megahertz. So this is dual conversion here. IF of 1500 KC and 455. Let's try go up to about 29 megahertz. Let's drop the amplitude down. One microvolt, can't hear anything. Let's try 3 microvolts. Well, that's not too bad. Two microvolts, that's at 29 megahertz. Let's go down. Let's go down to 3 point. Yeah, let's go up a little bit here to the amateur About 3.6 megahertz. Well, 1 microvolt, I can still hear it.
Hours, 52 minutes, coordinated universal time.
I don't know. Thing seems to be working all right now. Not the best quality. I do have to get a 608 ohm transformer here. But this is listening to WWV on 20 megahertz. Okay, here's WWV on 10 megahertz. Signal isn't that great, but you can hear it. If you're ever working on any equipment that has high voltages in it, always remember, ready kilowatt will kill you. Well, this might make a nice shortwave receiver, but being AM or ancient modulation, I don't know really what good it's for now. If I can get some documentation like this, it might be fun to tune it up and see if I can pull some more gain out of it, sensitivity. I can check the tubes. I can always put them on a tube tester and test them, but these old rigs are kind of neat, but really not good for too much, at least in my opinion anyway. Anyway, this is the GRC 14. Built like a tank, but made for a Jeep. Anyway, that's I think that's it for this one. Without any more information, I can't really do too much more with this right now. Anyway, thanks for watching. See you next time.